All right, good morning, folks. Just so that you have a chance to work through these problems. So these are the energy and frequency wavelength calculations. What you want to do is pay attention to which equation that you can use on top that's provided here. This one, this one, this one, and this one. Now, these are not only limited to these four equations. You can obviously manipulate some of them to a different format. For example, here, you can change that from this to this. Lambda over lambda is equal to C over nu. The reason why you can do that is if you divide both sides by nu, the nu's cancel out, which makes this equal to that. So therefore, it is important and also very important for you to recognize that there are ways to change these equations algebraically to make sure that they are equal to something else that you need. For example, here you're trying to find the frequency, which is represented by the Greek letter nu, 8.81 times 10 to the 6th hertz, and that's one of the given. The second part of the given is not really obvious because it's not really mentioned in the question, but you need to recall that we are probably going to be using some kind of equation, which is probably some form of this with the special derivation of it that is going to be essentially lambda is equal to the speed of light divided by nu. So the speed of light is given to you here. So 3.0 times 10 to the 8th can be included in this equation. So it's going to be actually 3.0 times 10 to the 8th meters per second divided by the frequency, nu, in this case 8.8 times 10 to the 6th power, hertz. If you plug it into the calculator, what you're going to get will be something times 10 to the, I think it's around going to be 0.6, I think, or 0.4 rather. And so it's going to be around 3.4 times 10 to the first power in meters. Now this one, the reason why we're only going to two significant digits is if you look at over here, the speed of light is given to you in 3.0, and that's two significant digits, whereas 8.81 is three digits. We're going to go with the least number of digits, so that's why we're going to go with two significant digits in terms of rounding out our answer. So what you want to do is highlight what's your answer whenever you have a chance to, because that way I can see clearly and it's easier for me to grade. Over here on question number 2, this one is a little bit different where you are given the wavelength in lambda and you're given it in nanometers. That's going to be a problem because we're going to want to convert that to meters in order to continue on with the calculation. So you have the wavelength given to you, and you are going to need to try to find frequency. This equation up here is a perfect fit for that. So therefore, you could just set it up as nu is equal to C over lambda. But the problem is you will need to do a calculation conversion to get the 650 nanometers into meters. So you should do that somewhere else. 650 nanometers. You can multiply that by, over here, you can see that nanometers, 1 nanometers is equal to 1 times 10 to the negative 9 meters. So therefore, you can have 1 nanometer on the bottom and 1 times 10 to the negative 9 meters on top. Once you do all the conversion, you'll figure out that this is 6.5 times 10 to the negative 7 meters. You're going to carry that over so that you can include it in the calculation here, where this is top part is still 3.0 times 10 to the 8th power meters per second. That doesn't change. Divided by 6.5 times 10 to the negative 7 meters. In this case, the meters can cancel each other out because they're the same thing on the two sides of the equation. So therefore, you can do that part. 3 divided by 6.5. It's -15. So if you put it in the calculator, you should get 4.6 times 10 to the -14. And that's going to be over a second. So how you get that is you want to make sure you have the correct number of significant figures, which is 2. 2 significant digits in the speed of light, as well as 2 significant digits here, and therefore you should round it up to 4.6, even though you should get 4.615384615, but that one you will just do that part. So for the first question through the sixth question, it's all very similar. You will need to convert micrometers into meters, millimeters into meters as well. So again, micrometers is 10 to the -6th. Millimeters is 10 to the -3rd meters. All right. Question 7, on the other hand, we're starting to get into energy calculations involving frequency or possibly wavelength. So the equation that you're going to use for this one is up here. E equals hv, nu rather. So if you carry that equation down, it's going to be equal E equals h in nu. You will need to find what h is standing for. So the h is 6.63 or 6.625 times 10 to the -34 joules second. So you would want to carry that down. 6.63 times 10 to the -34th joules second. What you want to multiply that by is the hertz over here, 2.68 times 10 to the 6th power hertz, but that's essentially per second. And what I want you to pay attention to is that the seconds can cross out. What you're left with is the unit joules. So therefore, it should be around 1.77684 times 10 to the -27th. But because each of these are 3 significant digits, I'm going to round it up to 1.778 times 10 to the -27th power. And the correct unit should be joule, because this is an energy unit. All right. Second part, it's going to be the same thing. In number 8, E equals hv nu. And I'm going to just rewrite that. There we go. So you're going to still do the same thing, 6.63 times 10 to the -34th power joules second. Multiply that by the 7.88. 88 times 10 to the 8th per second. This way you know that you can cancel out the seconds. And what you're going to get is, it's going to be around 5.22 times 10 to the -25th power. The reason why that is of course you're using the E equals h nu, Planck's constant, times the frequency here, and that should get you to this calculation. The next two are going to be a little bit more challenging because there are 2 parts here. For number 9, what you want to do is find E as well as find lambda. So the first equation is going to be E equals h nu. The second part is going to be equal to lambda equals c divided by nu. So the 2 parts are pretty straightforward, but you do need to do 2 different parts to get to the energy as well as the wavelength. So the first part is you are going to do 6.63 times 10 to the -34th joules second. No, joules second, not joules per second, but joules second. And multiply that whole thing by the 6.165 times 10 to the 14th hertz. and you're going to get an answer for that part. The second part you're going to do is going to take the 3.0 times 10 to the 8th meters per second divided by that 6.61 or 6.165 times 10 to the 14th per second. And hopefully you realize the per seconds cancel each other out, leaving you with meters as the end. Same with up here. What you want to do is just be aware of the fact that you can rewrite this as per second, and therefore the per seconds and per seconds also, or seconds and per seconds also cancel out. So what you're left with are two sets of calculations with the correct ending units, and you should be able to do that out. So make sure that you do know that you are aware that this is two different calculations, that you should be able to change between them. I'm not going to do all the calculations for you. Actually, no, I'm going to do all the calculations for you. Just hold on a moment. So that first one, it should be 4.09. There we go. Oops, my bad. I'm just going to write that 9 a little bit slower. Times 10 to the negative 19 joules. All right, undo. That should be a 9. That's not much better, but okay. Let's roll with it. The other part should be around 4.9 times 10 to the negative 7th meter. So just be aware that because this one has two significant digits in terms of the constant, and even though there is 4 significant digits here in the given, because this one's 3.0, the constant is 3.0, I would go with 2 digits in terms of the significant digits. And the same thing will be happening over here as well. But what you want to do for 11 is instead of that, you're given wavelength. So the two equations that you will be using are the E equals h, Planck's constant, times the speed of light, c, divided by lambda, which is the wavelength. So it's going to be E equal to hc over lambda. What you want to do is make sure you have all the parts. 6.63 times 10 to the negative 34th joules second times 3.0 times 10 to the 8th power meters per second, all divided by the lambda, which is 450 nanometers, but you can convert that to a fraction of within a fraction. Nanometers on the bottom. 1 nanometer is equal to 10 to the negative 9 meters. 1 times that number. The answer should be around 4.4 times 10 to the negative 17. Now, what is the unit that should be coming down here? It should be per seconds or in hertz, all right? And the other ones that you will need to do is you have to figure out what is the new value, which is also c divided by lambda. So you will need to do 3.0 times 10 to the 8th power meters per second divided by, I'm going to use a black line to separate these two parts, divided by lambda, which is 450 nanometers, but you should have converted it at that point, so it's going to be 4.5 times 10 to the negative 7 meters. And that should leave us with, it should be about 6.7 times 10 to the 14th power in per second term, because that should be the rough amount. And I apologize, I screwed up the unit above, because actually if we go through and cross out the ones, that should be crossed out. The seconds and the per second should cross out. Meters, nanometers cross out with nanometers, meters cross out with meters. So what you should have been left with is actually joules, not per second. So I do apologize, that first part, that was my fault. That's what's wrong with it. That should have been joules, and that's the energy part. So E is equal to that. And nu is equal to that. And that's the two answers here. So the answers are this one and this one. All right. I hope that helps, and see you in class.